Welcome to Moose and Chemistry. In this lesson, we're going to be dealing with balancing chemical equations. So we'll start off with a very simple equation, which is going to be nitrogen, which is diatomic, plus hydrogen, which is also diatomic. And that's going to give us a new compound, which we're going to call nitrogen trihydride. Now, what we can do with this equation is we're going to balance it. Notice that the nitrogens on the left side do not equal the nitrogens on the right side. You can see this, there are two nitrogens here, there's one nitrogen there. So we want to make sure that they're both the same. So the easiest way to do this is to set up a table. I call this the table method. And you're going to go N and H, and then N and H again. So now we have 2 here, and we have 2 here, we have 1 here, we have 3 here. So we know that we have 2 on our left, so we have to put a 2 right in front of this nitrogen. That changes that nitrogen to 2 and that hydrogen to 6, because that's 2 times 3. Now we need to make sure that we have 6 hydrogens over here, and we place a 3 in front of there, and we make that a 6. So now our equation is balanced. And that's an example of one of those. Let's look at a different type of equation this time. And we're going to go ahead and clear this drawing. And this time we're going to do another type of equation, which in this case is a decomposition equation. The last one was a synthesis equation. So we go KClO3 is going to decompose into KCl plus O2. Now again, we're going to set up a table. And this table is set up will look something like this, and we go K, Cl, O, K, Cl, and O. Now, when we look at this, we have 1 potassium, 1 chlorine, and 3 oxygen. Here we have 1 potassium, 1 chlorine, and 2 oxygens. Now again, we have 2 oxygens, 3 oxygens, so the least common multiple between 3 and 2 is 6. So we're going to want to put a 2 here. So when we do that, that becomes 2, 2, that becomes 6. So if we put a 2 in front of the K, we have to put a 2 in front of the K over here. That becomes 2, 2, and then we're going to put a 3 in front of the oxygen, and that will become 6. So now we have 2, 2, 6, 2, 2, 6. And that equation is solved. Let's look at another equation. This time we're going to look at a single replacement equation. So we're going to clear the drawing again. And now we're going to set up a brand new equation. This one's going to be NaCl plus F2 yields NaF plus Cl2. Now again, we're going to want to set up our equations by doing a table. Na, Cl, and F. Na, Cl, and F. Oh, notice that the F right here was the second one, but we didn't put it right there. That's because we want the left side and the right side to look exactly the same. So we'll take away those arrows. So now we have 1, 1, and 2, 1, 1, and, oh, wait a minute. We have a 2 there and a 1 there. So now we need a 2 in front of here. So that will give us a 2 and a 2. So that means we need a 2 in front of here. That will give us a 2 and a 2. And again, you can see that this side looks like that side. And so that is solved. Let's try something a little bit more complicated. So let's clear this drawing. And this time we're going to have a polyatomic ion in our equation. And so we're going to set up one, and we'll call it PbOH2 plus HCl yields H2O plus PbCl2. Now, in this situation, we're going to again set up a table. Now, some people think that the bigger they are, the harder they are. But I find that's quite the opposite. Now, notice that we have two H's on that side, so I'm going to list the H just once. And so we have the Cl there. And then again, no matter what that right side looks like, we're going to set up the table the exact same way so that it's easier to see the pattern. So we have one lead, two oxygens. Now we have three hydrogens because we have two hydrogens here and one hydrogen there. Add those two together, that gives you 3. So take those arrows away. And now we have one chlorine. On this side, we have two hydrogens, one oxygen, one lead, and one chlorine. Well, now we need to give chlorine on this side a 2. So when we do that, that changes that to a 2. But now look, we now add up our new hydrogens. We have two hydrogens here and two hydrogens there, which changes that to 4 hydrogens. So I'm going to go ahead and erase those arrows real quickly so we don't get confused by them. And now we're going to have to put a 2 in front of here because now we need 4 hydrogens again. So that gives us 4 hydrogens and 2 oxygens. So again, if we look at the left side, 1, 2, 4, 2. Let's look at the right side. 1, 2, 4, 2. They're exactly the same. Congratulations. Have a nice day.